Hello students, I welcome you all to this class. This is mathematics class, and here today we'll be studying this topic, integration. We've actually been considering this topic integration in our previous classes, but we have a special integral to perform here. So today we'll be looking at how to integrate some of these special functions. So we have a function of the form. You want to integrate a function of the form integral of f prime of x divided by f of x with respect to x. Then the result will be the ln of absolute value of f of x plus the constant of integration c. Of course, you know that ln is the natural logarithm. So what this thing is saying is that you have a function to integrate, and you notice that the derivative of the denominator will give you the numerator. The prime on f is showing derivative, so if you differentiate the denominator, you are getting the numerator. Then the result of this integration is the ln of the absolute value of the denominator plus the constant of integration c. The second one I wrote is integral of 1 over k f prime of x divided by f of x with respect to x. The result will be 1 over k multiplying ln of absolute value of f of x plus c, where your k should not be 0. So this one I wrote here is a situation whereby if you differentiate the denominator, the result is not giving you the numerator exactly. But if you divide, if you do 1 over k is a number, so 1 over that number multiplying the result of derivative of denominator will give you the numerator. Then the integral of this will be 1 over that k multiplying ln of absolute value of the denominator, that's your f of x, plus the constant of integration c. So we are going to use this format here to perform these integrals given to us. Let's write the function first. Integral of x divided by 3x squared minus 2 with respect to x. So f of x is the function at the denominator, right? The function at the denominator. So our f of x is what? 3x squared minus 2. That's our f of x. Then let's look at f prime of x. Let's differentiate. F prime of x will be, we differentiate 10 by 10, differentiate 3x squared. If you bring down this power, you are going to have this power, which is 2, multiply 3, you are going to have 6x. Then if you remove 1 from 2, you are going to have 1. So that's 6x raised to power 1, that's 6x. Then if you differentiate negative 2, you get 0 because they're constant. So the derivative of the denominator is giving us what? Gave us what? 6x. Derivative of the denominator gave us 6x. But what do we have at the numerator? We have x, not 6x. So that constant k, the constant k we have here is what? 6. So that our integral of x divided by 3x squared minus 2 with respect to x, the result will now be 1 over the constant. What is the constant? 1 over 6, right? Then multiplying ln of absolute value of f of x. F of x is this one, the function at the denominator, 3x squared minus 2. Then plus constant of integration c. So this gives us the result of the first one. So quickly we can as well integrate the second function, integral of tan x with respect to x. So we are going to write tan x in quotient form. So tan x is the same thing as sin x divided by cos x. So we are integrating sin x divided by cos x with respect to x. So what is at the denominator? What is at the denominator is what? Cos x. So we have that f of x is equals to what? Cos x. That's what we have at the denominator, right? Then we differentiate f prime of x. we look at the derivative of this function. F prime of x will be equal to, if you differentiate cos x, you get negative sine x. That's what you get. Then what we have at the numerator is sine x, not negative sine x. So guess what that constant is? So that constant multiplying the quantity at the numerator is what? This minus here, that's minus 1. That's the constant k. So this implies that k is what? Minus 1. Right? So that integral of sine x over cos x with respect to x will be 1 over, we say 1 over k from the formula, 1 over k. Our k is minus 1. 1 over minus 1 ln of absolute value of our function f. That's cos x plus constant of integration c plus c, right? So this 1 over minus 1 is minus 1. So this is just like negative ln of absolute value of cos x plus what? C. We look at the question C. Question C is integral of the x divided by 2 minus 5x. So let's look at this question C. Question C is the integral of the x divided by 2 minus 5x. That's what we have in our question C. Of course, this is the same thing as integral of 1 over 2 minus 5x dx. Right? By just pulling out this dx, then what we have at the numerator is what? 1. So that clearly our f of x is what? 2 minus 5x. That's the quantity at the denominator, the function at the denominator. So f of x is 2 minus what? 5x. F prime of x will be equal to, that's, we differentiate this function. If you differentiate 2, get 0 because the constant, we differentiate negative 5x, which will give us negative 5. Negative 5, right? But what do we have at the numerator? What we have at the numerator is what? 1. What we have at the numerator is 1. But negative 5 is what? Negative 5 is same as negative 5 multiplied by what? 1. The derivative of our function f is equal to negative 5 multiplying what we have at the numerator. So our constant k is what? Negative 5 in this case. So that integral of the x divided by 2 minus 5x will be equal to 1 over k, from the formula 1 over k, that's 1 over minus 5 ln of absolute value of f of x. Our f of x is this quantity here at the denominator, 2 minus 5x plus constant of integration what? C. So if you simplify, the negative 1 over negative 5 is same as negative 1 over 5 ln of absolute value of 2 minus 5x plus c. So this brings us to the end of this class. So I'm expecting in our upcoming class we'll solve more examples on this topic, integration. Thank you so much. Bye.